Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, find the critical points for the function. Use the first derivative test to determine whether the critical point is a local maximum, local minimum or neither. Then find the x and y intercepts and sketch the function. So let's first find the critical points. Now critical points are points at which the derivative of the function is equal to 0 or undefined. So we'll start by finding the derivative of this function. So the first step is y prime. Now this is a polynomial function. So we'll have to find the derivative of these three terms using the power rule. So as per the power rule, the derivative of x cube is 3. So we move the exponent to the front of the term and then x, and then we subtract 1 from 3 and then plus. So in the second term 3 is the coefficient, so it stays as it is, and then we move the exponent 2 to the front as per the power rule, and then we subtract 1 from 2 and then plus. Now the derivative of 1 is 0 because 1 is a constant. Now we can simplify this expression. So y prime equals 3x squared plus 6x. Now there is no x value that will make this y prime undefined because there is no x in the denominator. So we just have to find the x values that will make the y prime equal to 0. So we'll set the left side equal to 0 and we have to solve this equation. So now we can do common factoring on the right side. So we can factor out 3x, and in the parentheses we get x plus 2. So now we get two cases. So the first case is 3x equals 0, and the second case is x plus 2 equals 0. Now we can solve for x from both cases. So for the first case, we'll divide both sides by 3. So the 3's on the left side will cancel each other out. So we get x equals 0. So this is the first critical number. And from the second case, so we should subtract 2 from both sides. So the 2's on the left side will get cancelled out. So we get x equals -2. So this is the second critical number. Now we can find the y coordinates for the critical points by subbing in these x values one by one in the given function. So for x equals 0, we get y equals 0 cubed plus 3 times 0 squared plus 1. Now we can simplify this. So 0 cubed is 0, 3 times 0 squared is 0. So we are left with just y equals 1. So the first critical point is 0, 1. Now for the other critical number x equals -2, we should sub in x as -2 in the given function. So -2 exponent 3 plus 3 times -2 squared, then plus 1. So we get y equals, so -2 to the power 3 is -8, and then -2 square is +4, and 3 times 4 is 12 plus 1. And if we combine these numbers, we get y equals 5. So the second critical point is -2, 5. So these are the two critical points for this function. So we are done with the first part. Now we have to use the first derivative test to determine whether the critical point is a local maximum, local minimum, or neither. So for that, we'll use the number line method. to find whether the derivative of y is less than or greater than 0 on both sides of these critical numbers. Now we know that if the derivative is less than 0, that means the function is decreasing on that interval, and if the derivative is greater than 0, then the function is increasing on that interval. So we'll draw the number line and we'll show the critical numbers. So the critical numbers are 0 and -2. So let's assume this is -2 and this is 0. So these critical numbers divide the number line into 3 parts. So we'll have to use a test value from each part and sub in that test value one by one in the derivative of the given function. So on the left part we can use the test value -3. In the middle part we can use the test value -1. And on the right part we can use the test value +1. Now we found that y prime is equal to 3x squared plus 6x. So we'll use this equation. So let's start with -3. So we'll sub in x as -3 in the y prime equation plus 6 times -3. So we get y prime. So -3 square is +9 and 3 times 9 is 27. And then 6 times -3 is -18. So we get 9, which is a positive number. So that means to the left side of the critical number -2, the y prime is positive. That means the function is increasing on the right side of, on the left side of -2. Now we can use the test value -1. So we'll sub in x as -1. So 3 times -1 squared plus 6 times -1. So we get y prime equals, so 3 times +1 because -1 squared is +1, and then 6 times -1 is -6. So we get 3 times 1 is 3 and -6 is -3. So since y prime is a negative number, that means the function is decreasing on the right side of -2 because y prime is a negative value. Now we can use the third test value, which is 1. So we sub in x as 1 in the y prime. So 3 times 1 squared plus 6 times 1. So 3 times 1 square will just be 3 and 6 times 1 is 6. So y prime equals 9, which is a positive value. So that means to the right side of 0, the function is increasing. Now we have to analyze the increasing and the decreasing property of this function to identify which critical point is local maximum and which one is local minimum. Now let's start with the first critical number. So x equals -2 on the left side. So on the left side of -2, the function is increasing because y prime is positive. But on the right side of x equals -2, y prime is negative. So function is decreasing. So that means there is a local maximum at -2, 5. So that's the critical point we found. Now we can analyze the other critical number, which is x equals 0. Now to the left side of x equals 0, the function is decreasing because y prime is negative. But to the right side of 0, the y prime is positive, so the function is increasing. So that means there is a local minimum at 0, 1. So there's a very important concept you need to understand and memorize for this type of analysis to identify local maximum and local minimum using first derivative. Now we can answer the third part. So we have to find the x and y-intercepts and then sketch the function. So we can use a different color for it. So let's start with x-intercept. So for x-intercept, we sub in y as 0 in the given equation and then solve for. Now this is a cubic equation and we cannot solve this equation using factor theorem. So in this case, it would not be possible to identify the x-intercept for this function. So we will have to use a calculator to identify the x-intercept. So now we can analyze the y-intercept. So for y-intercept, we sub in x as 0, so we get y equals 0 cube plus 3 times 0 square plus 1, so which is equal to 1. So the y-intercept is 0, 1, which is also the local minimum. So now we can use all of this information to sketch the function. So we'll start by plotting the local max and local minimum. So we identify, so let's assume this is -2. So the local max is at -2. So let's assume this is 5. So -2, 5. So this is 1 point. And then the local min is at 0, 1. So let's assume this is 1. So this is the local minimum. Because 0, 1 will be on the y-axis. Now we couldn't identify the x-intercept, so now we can use the increasing and the decreasing analysis. Now on the left side of x equals -2, the function is increasing. So that means from left to right side, the graph is sloping upward. And it reaches all the way up to the local maximum. Now on the right side of x equals -2, the function is decreasing. So it should slope downward all the way to the local minimum. So any tangent that we draw to this part of the graph should have a negative slope. And then to the right side of 0, the function is increasing. So as we go from left to right, the graph should slope upward. So this can be the sketch of this function. Now I use technology to find the x-intercept of this function as -3.1, but I couldn't figure out a way to do this using factor theorem. So if anyone has any ideas on how to find this using factor theorem, please share it with me. So these are the steps you have to keep in mind to solve this problem. So you have to keep in mind that we have to first find the derivative of the function to identify the critical numbers, which we use to identify the critical points, and then we use the first derivative test. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.